Okay, so this is an overview of my 8 puzzle solver for ECE 479 at the U of A. Basically, this driver, the puzzle solver driver, gets this input file, just all these different 8 puzzles in row major order, and for each one of them it scans in a node. That is basically just the state of the board here, with some other information about this, like the Hamming sum and the Manhattan number. And so this loops 3 times, and it makes this array list of parent nodes 3 times, just so that references don't get mixed up. And finally, once it's done reading the file, we start to write to our out file. So we make an array list of a pair of node double, which I will get to in a little bit. And for each of those nodes within the parent node array list, we're going to do node.findSolution, and we're going to pass in a little argument. The argument is our method of solving, so whether that be the depth plus the Hamming sum, or the depth plus the Manhattan number, or whatever. Basically, this is just that heuristic or whatever, that function is basically, we're using that for our A-star algorithm, which is right here. We just expand the node, add all the children of the node to the frontier. We sort those nodes, so the best A-star candidates are going to be at the top. We get the top node and pop it from the queue. And basically this other stuff right here is just so that we can do logging for the iterations and average branching factor. And so it'll do this and eventually finish and return a pair that contains our current node and the average branching factor for this problem. The way it sorts the nodes is up here, so I'm implementing this custom sorter, so I can just call collections.sort. So H3, H2, H1, those all correspond to our heuristics, whether that be Hamming sum or Manhattan sum or a combination of the two. And that basically, this right here pretty much just calls, or just does the A-star search algorithm for each node. Some other things that might be worth mentioning is this other expand function that just takes in an integer. So it's going to expand a node to a certain depth and just generate a big tree in memory. That was more so I could get these test cases. I just pulled the ones at a depth of 5, 10, or 15. And then there are some other things like, let's see, report sequence. So when I find a solution node, I want to see the path that it took to get here. So this is just a recursive function that is going to call it on its parent until there is no more parent. And then it's going to return basically whatever node to string, which is overridden elsewhere in the code. And it'll basically generate something that I can show you right here. If I go ahead and run puzzlesolver.java and refresh. So now we have all these output files. So here is the node that we began with, 813 blah blah blah, right here. And then this is the path to the solution. It moves the blank space left, up, up, right, and down. And then there we go. So this took just 5 iterations, and it was pretty simple. See, this one took 15 iterations, so you notice that the number of steps and iterations aren't always the same. And then the bigger ones, the bigger problems that took like 15 steps take a lot more iterations. And then here's the branching factor for each problem set. You can see the set average branching factor. It'll say end of the problem set, and then all the way at the end of the file it gives you the overall branching factor. So I believe this was using just the displacement as a heuristic function. This is using the Manhattan, and then this is using both the Manhattan and the Hamming sum as a heuristic. So that's running the program and a basic overview of what it does. Here are my setters and getters.